So last time we were here, guys, we talked about some definitions. And you got to take me seriously. All right, so here we go. So we're going to begin our look at fractions. Fractions are a basic part of the numerical system that will never go away. So we're going to talk a little bit about fractions and the basic rules of fractions. Then we're going to go through some actual operations working with fractions, right? So today we're going to just kind of introduce some basic rules and basic ideas of fractions. First of all, remember that when you have fractions, you have two parts. The top part is called the what? Numerator. Excellent. The bottom part is called what? Denominator. And anytime that I'm working with fractions, I'm always going to use the abbreviations capital N and capital D. Capital N means numerator, capital D means denominator. So I'm never going to use those letters for anything else. So if you see a capital N, you know it should be, that means the what? The numerator. There you go. Good. Okay. All right. Now, there are some rules with fractions that are different than rules with whole numbers. They don't behave the same way. And the reason for it is the very definition of the fraction. If you have some numerator over some denominator, what that literally means is to take the numerator and divide it by the denominator. So in other words, a fraction is really not even a number. It's a mathematical operation. And that's why they don't behave like other numbers. All right, so you've got to be careful when you're dealing with fractions to follow the rules for fractions. Okay? And you've got to keep an open mind and realize, hey, that's why they don't behave like regular numbers, 2 times 4, right? Because they're not numbers. They're fractions. They're division problems. Okay? So really, a fraction is not a number. It's a division problem. Now, the first rule for working with fractions is that you always have to simplify them, if possible.
Do you put this in the steps?
Yes, this is just in your notes. Yeah, sure. Okay? Well, same thing. All right? Now, simplify if possible. And when you're simplifying, there are several things you need to look at, okay, in order to be able to simplify them. First, you should ask yourself, well, first of all, you need to think about it as a division problem. So first, can you divide the numerator by the denominator? Because ultimately, it's a division problem. So if you can divide, then that's always the first thing you should do. So for example, say we have 8 over 4. Really, this fraction is actually just a division problem. That's 8 divided by 4, which is what? 2. And notice that because you could perform the division, it's no longer even a fraction.
Do we need to write things down?
Yes, of course. Anything that I take the time to write should be important enough for you to write. Okay? Now, if you can't divide it, you might be able to simplify it. You might be able to divide away any common factors. Exactly. Divide away any common factors, numerator to denominator. So anything that's common to both the numerator and denominator. Remember factors, we discussed that last time we were here. Factors just mean things that are multiplied together to give you a, what's the answer? Product. There you are. Okay? But what we have is the product. We're going to be looking for the factors. So if things multiply to make something, that means those factors will divide evenly into the product. Right? Because anything that multiplies together to give you a number will divide into that number. Does that make sense? Okay. Okay. Pardon me? Yeah, Roman numeral I, just a big group, big heading. Okay? All right. Now, we're going to talk about ways of doing this. In most cases, if the numbers are small, you can just kind of look at it. But I'm going to show you another method for doing this. So because remember, as you move forward, guys, as you move forward, then the numbers aren't always going to be just 2s and 4s and 6s, right? So you're going to need to think about a process that will allow you to do bigger numbers and stay focused while you're doing it. So I'm going to show you a process for doing that. So here we have our steps. To do this, we're going to use, don't write A first. We're going to use upside down division. Now, it's going to look weird at first, but trust me, it's a phenomenal method, especially when the numbers are big. And we can also use it to do some other stuff. And so I want you to learn this process. It's really easy. Put the numerator and denominator in an upside down division symbol. Hold on, just write it down. I'm going to show you an example so you can see. Put your numerator and denominator in an upside down division symbol. Okay? So, let's get an example going here so that we can see. So say, for example, we have 116 over 124. Can anybody quickly tell me what the greatest common factor is, what that simplified fraction should be?
4. No, not 4.
You divide it by 4.
Well, we can divide by stuff until we find out what it is, but really it's difficult to tell. When numbers get big, it's difficult to tell just right off the bat what it's going to be. But that's no big deal. So what we're going to do is we're going to write an upside down division symbol. No, we're going to write an upside down division symbol. We're going to put our numerator and our denominator in it. Okay?
Isn't that called a bus stop?
Okay.
There's a bus stop division.
That's so extra.
Okay. Never heard of it. All right. Doesn't matter what it's. You can call it anything you want to. All right. Second. Divide out any common factor. CF, common factor. You can write out common factor if you need to. Common factor. Now, it doesn't matter with this method. It's not about speed, it's about accuracy. So my advice to you would be to go with obvious things. And you have a calculator to be able to do this. Everybody got your calculator out and ready to go, because I'm not doing the math. Y'all are. Okay.
Use the calculator to find
Because I don't want you to. You have to think about always. All right, here you go. So if you look at 116 and 124, they're both even, so you'll know they'll at least divide by what?
2.
By 2. So let's divide them by 2. What's 116 divided by 2?
58.
Pardon? 58? What's 124 divided by 2? 62. Okay? Now, sometimes dividing once is enough. But in this case, 58 and 62 will at least divide by 2, so you know there's still a common factor, right? So what we're going to do is continue to divide until there are no common factors, yeah. Okay? So, draw another division symbol. So what we're doing is we're separating the stuff we're working with from the stuff we get. And see, if you notice, there's 2 of them. So a while ago, several of you said that 4 would divide into those numbers. So I could have divided by 4 in the beginning if you saw it, right? But even if you just divide by 2s, you're still breaking the number in half, which makes it much smaller. So let's divide by 2. 58 divided by 2 is 29. 62 divided by 2 is 31. Now looking at 29 and 31, they won't divide by 2 because they're not even, right? Remember we talked about that last time? They divide by 2 if they're even. Will they divide by 3? No. You could look and look and look and look, and you're not going to find anything because these 2 numbers are both, anybody know, prime, right? So we're done. Now that doesn't mean you're always going to get prime numbers at the end. But in this case we did. the answer, which is the reduced fraction or simplified fraction, is on the bottom. What two numbers did I end up with on the bottom? 29 and 31. And remember, this was our numerator. The first one was our numerator. The second was our denominator. So my reduced fraction is 29 over 31. Now again, you don't have to do this with small numbers that you can see in your head. Okay? And yes, you can just simply enter the fraction in your calculator and hit enter, and it will reduce it for you or simplify it for you. But, and we're gonna focus on that, but that's not the only use for this that I want to show you. Yes?
Isn't this basically like calculating the LCM minus 1 stuff?
Yes. We're just doing it in pieces. Mm-hmm. Okay? All right. It's a GCF actually, but it's okay. All right, so now here we go. So you can do this with any of them. And again, the reason I'm showing you this process is not for reducing fractions because there are other processes. The reason I'm doing it is because you can do so much more with it. Because later we're going to have to add and subtract and multiply and divide and work with fractions. There are some other pieces we're going to build when we're building on the number system. So this system really is effective at doing lots of different things. And you'll see it as we go. And was it difficult?
No.
Was it very organized?
Yes.
Okay? And that's going to be a key for what you need to do. As the numbers get bigger, as life gets bigger in your mathematical operations, what's going to happen is you're going to need to stay as focused and organized as you can. You're going to be moving away from doing a lot of things in your head and writing things on paper. You're also going to have to be careful with the calculator. Because can you make a mistake when you're entering things in the calculator?
Yes.
And are you going to know it when you get the answer? No. Most of you just write down the dumbest answer you've ever seen in your life because the calculator says that's what you get. Even if you made a mistake, right? So you've got to be careful and have some idea of what's happening without the calculator. Okay? So we're just going to go through some fractions and simplify them. Some of them are going to be bigger where we can use this system. Some of them we're just going to be able to see the common factor and be able to divide it away. So these are just examples, but I want to write big, so you're going to pretend you're on that side of the page. Okay? Now, say you had a fraction like 3 over 12. Now,
Divide by 3.
right. What's common to both 3 and 12? 3. So you could simply divide both of them by 3. What's 3 divided by 3?
1.
What's 4 divided by 3?
4.
4. So you don't need a complicated system to be able to do it when the numbers are small, right? It's when they're bigger. And let me show you what's going to happen. As you move forward in algebra, you're going to be taking things that look like this and dividing them and reducing them. You think you need to have an organized method, very focused, and stay organized for that one? You bet. And so that's why it's important that you build good habits now. Okay? We have a tendency to only want to do what we are familiar with and what's easy for us, right? And we don't believe it when teachers say we should do things differently. But do you think you can do that one in your head?
Yes.
Which one? That one. Isn't it?
It doesn't have any multiplications.
Nope.
No, it's not.
Nope.
Okay.
Yes?
Like, when are we going to do stuff like this?
This will come. Well, depends on which direction you take. If you take the statistics, you'll never do it. But if you take math, it'll happen like in year, probably year 11, 12.
You're 11. You're 11.
That's not that far.
We did it last year in next May.
We did this in like
Okay.
we did this in like year 7.
No, we did it here.
You divided.
Because
All right, here we go. So, anyway, come on, guys. So, say for example, you have, I don't know. I keep giving you easy ones. What's common to both of those?
Divide by 2.
doing
They'll both divide by 7. 7 divided by 7 is 56 divided by 7 is 8. So your reduced fraction is 1 over 8. Guys? Okay, now. All right. What if I have something like this? Is there anything that will divide evenly into 3 and 4 at the same time? Nope. So it just stays 3/4. Okay. All right.
I'm not writing these.
That doesn't seem to be my problem. All right. Now, another thing. Another thing that you need to be familiar with fractions is that any number can be written as a fraction. Okay? Just get it off your neighbor's paper. Any number can be written as a fraction.
Oh, what? You just got rid of it.
So, any number can be written as a fraction. So, for example, if you have the number 3, how can I write that as a fraction?
3 over
1.
Right, we'll simply put 3 over 1. Okay? Right? Now, guys, settle. Now, this notation, 3 over 1, is never acceptable as an answer.
Because the bottom is lower.
So you should just go ahead and divide 3 divided by 1 to get 3, right? But will be times when you're doing operations where you're going to need to write the number as a fraction. And so you can always write any number as a fraction by simply putting it over what?
1.
Over 1. Good. Okay? Here's another thing that we need to talk about, and this one is a very difficult concept for students to grasp sometimes. Well, don't worry about it. Anything divided by itself equals what number? 1. No matter what. Okay? So 6 divided by 6 is what? 1. Right? Now, in this course, we'll be working, in this particular section, we're going to be working with only numbers, but later we're going to be working with algebra as well, which means and the only difference between algebra and arithmetic is the introduction of those letters called variables. So I want to show you this. A divided by A. What do you think that's equal?
1.
Exactly. Anything divided by itself is always 1. Yes?
For the students, I don't know much about imaginary numbers, but do they apply?
Not particularly here, but you could do division with them, but yeah. Okay? And I don't know if we'll talk about them in this course or not, but we'll see. There we go. Okay. All right. So, those are some of the basic ideas about fractions. Okay? Now, you have to remember that all of these rules must be applied. So we're going to be dealing with a lot of fractions, and if you don't reduce a fraction or simplify a fraction, then what can you conclude about your answer?
It's wrong.
Here you go. So no matter how it goes, no matter how you get it, what operation you do, you have to be able to simplify them. All right. Now, how much time we got? We got time left. So the next thing we're going to talk about is we're going to begin our operations with fractions. Guys, remember that operations, there are 4 operations. What are they? Add, subtract, multiply, divide. And the easiest one to do with fractions is, guys, is to multiply fractions. Right. So that's the one we're going to start with.
I've already done I. Can I do I? Wait, is this a step to how to multiply?
This is the introduction of this topic, to multiply fractions.
Are we learning how to multiply?
We're going to learn how to multiply them step by step. Yep. Okay. To multiply fractions. Guys, most of you have learned that to multiply fractions, you just multiply straight across and then you simplify. I'm going to tell you that that is not going to work anymore. Because what happens if you do that is, especially with the algebraic ones, is that you make things much bigger than they need to be, and then it's very difficult, if not impossible, to simplify them.
I forgot how to do that.
So do you
Okay.
simplify then multiply?
Exactly. So, let's write out our steps. First, simplify. And remember, simplify simply means to divide away any common factors, numerator to what? Denominator. Simplify first. And when you're simplifying, if you're talking about multiplying fractions, you can't multiply unless you have at least how many fractions? Two. Okay, simplify first. And when you're simplifying, because when you're multiplying, you're going to have at least two fractions, right? You could have more. You can simplify any numerator to any denominator. It doesn't matter which fraction it's coming from, as long as you're going from numerator to what? Denominator. You have to be crossing that fraction bar or you're not allowed to divide. Doesn't that make sense? Because the fraction bar literally is the division symbol. Once you've simplified it completely, then you're simply going to multiply straight across. So it's a reversal of what you normally do when you're learning these in primary school.
So multiply numerators.
So it's numerator times numerator, denominator times denominator. Okay? So, simplify first, any numerator and any denominator. So let's just do some easy ones. It doesn't matter. The process stays the same. So we have 4 over 5 times 25 over, I don't care, 16. Now, I know that this is going to give it an improper fraction, but we don't really care. What operation is indicated by the dot, or you can also use an X? Multiplication. And I'm multiplying with what numbers? It's a 16, yes. And I'm multiplying with what kind of numbers? Fractions. Do fractions multiply the same as whole numbers? No. So, what we need to do is we need to go to our rule, which says that before I multiply, I must first simplify. And I can simplify any numerator to any what? Denominator. What is the first number in the first numerator? 4. Do 4 and 5 have any common factors? No. But it doesn't matter but I also need to check the other denominator as well, because it's multiplication. What do 4 and 16 have in common? 4. So 4 divided by itself will make a what? 1. 16 divided by 4 will make a 4. Okay.
Why do you simplify across?
You simplify because it's any guys. As long as it's multiplication, you can simplify any numerator to any denominator. Doesn't matter. Okay? But only if it's what operation? What does that mean, the X? Only if it's multiplication. You can't do this with any other operation. Now, the next numerator is 25. 25 and 4 don't have anything in common, but 25 and 5 will both divide by what? 5. 5 divided by itself will leave a 1. 25 divided by 5 is a 5. And now that I've simplified, I'm going to multiply how? Straight across. So 1 times 5 is 5. 1 times 4 is 4. And you end up with 5 over 4. And yes, I want you to leave it as 5 over 4. Okay? One thing that many students think is that changing 5 over 4 to 1 1/4 is simplifying. That is not simplifying. That is converting.
That's synthetic.
All right? So simplify means divide away common factors. What we've done to change 5 over 4 into 1 1/4 is convert it to a mixed numeral. That's not simplifying. Now, many times, though, you'll want it in this form. But in algebra, which is where you're going, you do not want it in that form because you can't multiply or divide or anything with it. Guys, but you can, the reason why you would do this and why you should is if you're using fractions in, say, a story problem or an application. For example, if you want to say how many hours of my life I've lost because of students not paying attention, then I wouldn't say I've lost 5/4 of an hour. I would say I've lost 1 1/4 hours, right? So if you're using, or 1 1/4, same difference. If you're using fractions to describe something or as a unit, then you always would convert them into mixed numerals. But if you're using them in mathematics to answer a question in mathematics, then you would use an improper fraction where the numerator is bigger than the denominator as your answer, right? So do you see the difference? So hold on a second. If I was using this as how many miles I traveled, for example, or kilometers, how many kilometers? Would I use 5/4 for kilometers or 1 1/4? 1 1/4, yes.
So if we would do 4 times 25 and 5 times 60, it wouldn't give us the same answer?
Well, it would, but then you'd have to reduce it. And so if you took, that would give you 100 over what? What's 5 times 16? 80? And then you would have to reduce those big numbers. But if you reduce first, then the numbers become much smaller, much faster. Now, these are pretty easy ones to do.
That's a faster way to do it.
It's a more efficient way of doing it. With some numbers, it's faster to do it the other way. Now, let me show you where you're going, though. If we're going back to algebra, say we had something like this times something like this. All right? If you didn't reduce this first, you would never get the right answer. If you just multiplied these two together and got something, and then multiplied these two together and got something, you would never be able to fix it. Ever. I'm telling you, it's not going to happen. Okay? All right? Well, don't worry about this. This shouldn't make any sense to you. Okay? No, this won't work. I just made these numbers up, so it's not going to happen. All right? So, anyway, so it's not about where you are with basic fractions. It's where you're going with the algebraic fractions. That's why you need to learn the good habits of reducing or simplifying when? First. Okay? Yes, it would work to multiply straight across and then simplify. But it's the better habit. I bet you don't.
No, it's minus 820.125.
No, it's not.
It is.
There's no number. You don't know what X is.
Well, it just said that. Look.
Well, that's just because you put stuff in there.
Well, it obviously worked out what X was.
No, it doesn't know what X is.
X can be anything.
Okay. You couldn't get a number out of that, but you could get a simplified reduced fraction. No, X could be literally anything in that case. All right. No. Okay. All right. So it's not about yes, you could multiply straight across and simplify when it's just numbers and they're small. But later it's going to become a very bad habit. Okay? All right. So what we're going to do is I'm going to give you an assignment in Education Perfect about multiplying fractions. You can start working on it now. Okay. Now,